Okay, so soft jaws, guys. Soft jaws are like the first tip of the iceberg when it comes to fixturing, and they're probably one of the most common that we use a lot. Um, Especially in job shop, one-off part, simple setup stuff. A soft jaw is a great tool. They're consumable, and when you're just trying to make a onesie twosie, it's probably going to be the way you do it. A lot of stuff I did in industry because we did mostly prototypes. Maybe the biggest runs that we did in-house were 10 to 20 parts. So everything else we sourced out production-wise. We didn't do a lot of production because we only had a couple machines, so they were busy developing stuff, and then we were sourcing stuff otherwise. So soft jaws, this is a set of hard jaws that somebody cut at some point, and they've got a pocket cut in them. And basically what you're doing is you're taking your part shape and you're cutting a pocket that is a negative of the part shape in the jaw so that it can hold on to it. Now this is the example of what not to do, because this has an undercut in it, meaning that the jaw here is cut backwards up into that contour, and if you went to open this vise, this will not pull apart. Okay, you have to clearance undercuts. You basically have to clearance interference corners, so anywhere the tool can't get into and actually cut the corner, like a sharp corner, you have to go in and cut a fillet corner and clearance it out. You have to do that, and then also anywhere that there's like an undercut where a radius turns back into itself, you got to clearance that out too. The jaw just has to have enough material to hold the part and locate the part. Okay, that's what you're trying to do. Hold the part, not have it fly out, and also locate it in X, Y, and Z. Okay, so left to right, forward and backwards, and then obviously the bottom of the pocket that you cut into it's what's going to hold it in Z. That's how we locate it in Z. So right now we're going to go through the steps of how to create soft jaw pockets. This is basically the steps that I use still today. Anytime I use soft jaws, these are the steps I go through. And you do it enough that you get to where you can just boom, 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 and you can create this really quick. All right. Now, some of you have already signed up and went on and done the form for the advanced class. Some of the stuff we do in the advanced class, we go a little deeper. We try to, we do a fixturing project where you actually have to create a fixture. Okay, so you're going to make a station fixture. We'll look at one of them here in a little bit. You're actually going to take a soft jaw and you're going to make a progressive soft jaw. So think about what you're doing with your die project out there. You're making a progressive die. Every station, something else is getting done, correct? We're going to make a soft jaw fixture that goes in the vise that you load your raw material in on the left side, and it goes through 3 stations at least. I've got an example I'm going to show you of a Lego that had 4 stations. Okay, but basically, once it comes out of the 4th station, it's a finished part, and it just keeps moving to the right through each station. That little application can be scaled up hugely, So, we're calling that a progressive fixture. Sometimes you might see what they call like a gang fixture, which means that you're holding all kinds of parts for setup 1, and maybe you're running like 100 pieces at once, but they're all doing the same operation. And then you load them all after you take them out, you load in another set, and now they're doing all operation 2. Okay, and you'll have a whole lot of pieces in there at one time on a fixture plate or whatever it might be, a vacuum table. There's all kinds of ways to hold on to parts in the fixture. And Flying S a couple weeks ago when they had that little open house, I wish more of you would have came over or tried to. They've got some crazy fixturing that they do with some of that stuff they deal with. They're dealing with aerospace parts, they're dealing with carbon fiber, really thin stuff. A lot of their fixturing, some of it is vacuum, so they're holding parts with the vacuum table stuff. Some of it, they hold like the carbon stuff that's got really complex shapes. They'll cut a negative of the shape, or the mold basically. Basically they'll cut the mold that's a fixture, they'll sit the part down on top of the mold, and then they have an actual hat, I call it, that's been 3D printed that goes over the top of it, and it's got magnets in it, and it holds the carbon part down as they go around the edges and do all the trimming to cut it to the actual shape from the mold after it comes out of the oven. There's some really neat stuff, and a lot of their fixturing that they do over there is pretty high end, so it's kind of cool, because I tell everybody you can be unbelievable at Mastercam. Okay, you can know all your speeds and feeds, but if you can't figure out how to hold on to your part and locate it in a productive way, you know, you're still up the creek without a paddle. Okay, this is where it's at. This is the big part of it. Figuring out how to hold the part. I can cut the part. Okay, I can set up the machine. I can do all that. How am I going to hold on to that part? And the other thing is, a lot of times I don't want to have a part that's 4 inches oversized. You know, a whole bunch of material of me just clamping on a vise all the time. You know, the less material I have to remove later, the better. So, all right, we've talked about that. Now it's soft jaw time. Let's create a new level. Let's just call this our soft jaw geometry, or wireframe, whatever you want to call it. I've been saying wireframe, so I should probably stick to that method. Same difference. I'm going to shut everything off except for my solid. Oops. So I'm going to leave my solid on, but I'm going to shut the other 2 wireframe levels off. I'm going to make sure my soft jaw wireframe is my active level. Okay, so here's step number 1. I'm not creating my level, but this part. I got to decide, whenever I hold this part in the jaw, how much of this part do I need to hold on to? Okay, how much do I need to hold on to it? And I'm going to do that by setting a Z depth right here. We're on the top plane still. I got to tell it, okay, when I hold this, I'm going to hold on to, you know, X amount. Normally I tell you, you know, as little as possible. You know, the less you have to cut down into the jaw, the more more use you're going to get out of that jaw. So if I can hold on to 125 thou or less of the part in my soft jaw contour, I would do that. And in this case, we don't have that option because this has this step cut here, and I need to be able to locate off of this entire shape here. So when we cut our pocket down in the jaw, I'm going to cut it at least to where it's cutting this outer contour here. So I'm going to right click and hit my Z depth down here. You could also click on the Z down here. I haven't ever showed you that, but you could also click Z down here and it works just the same. And I'm going to set this right here at the bottom of this island here. So here's the top of the step. I'm going to put it at the bottom of this center section. Should be negative 327 and some change. 327.5. So I'm going to tell it, you know what? I'm going to have 17.5 thou sticking up out of the vise when we flip this over and cut this pocket. So I'm going to add 17.5 back to that and set it at negative 310. Promise, if you're sitting here going, okay, I have no clue where he's going with this, stay with me. You will when we get to the end. Okay, you'll see what we got going on. I don't expect you to know just yet. All right. Yeah.
So I set the Z to the bottom of the step, and I move my mouse and it changes.
That's because your mouse is like
Not 2D.
2D.
Select the Z.
Yep.
Select my point.
Click on it.
Click on it. Sets it to
327.5.
Yeah. Then I move the mouse, switches to 670.
The Z does. Pause. So with it at negative 310. Oops. What just happened? I subtracted. Plus. There we go. Negative 310 with it over the top. I'm going to pick my solid. Okay. And I'm going to go to bounding box. This is the second step after I get that depth decided on. I'm going to pick my bounding box. I'm going to make sure it's on lines and arcs. And what I want to do is I want to create a bounding box that would represent the top edge of one of my soft jaws, meaning the top edge here of my soft jaw. Our jaws that we made out there, that you made, that you're going to use, we made them 6 inches long, right? We made them 6 inches long because they were cut a little short. We couldn't do that 6 1/4. Somebody sawed them. I'm not pointing fingers, but somebody sawed them a little short. Okay, so we're going to go 6 inches by 1 inch. So that's what we're going to type in up here with it anchoring off the center of the part. We're going to tell it that the X is 6 inches and the Y is 1 inch. And I'm going to hit OK. Melvin, I might use this video for years for soft jaw creation. True story. All right.
Forever in infamy.
Now that we've selected that, hold shift and pick that rectangle. That rectangle represents one jaw. We need to open up the vise, so we have two. You're like, there's no vise on my screen. How'd I do that? Well, it's just kind of a word play on something, because what we're going to do is we're going to do a transform, translate. Transform, translate. We're going to set it to move. And then down at the bottom of the translate menu, there is both sides. Set that to both sides. So when we open the vise, our vise jaws are moving in Y. So if you start increasing the Y value here, get to 0.5, right there would be two jaws completely closed. Okay, we're thinking of those object lines, that wireframe edge. Okay, now we've got to decide something here. So I'm not sure how many in here know about the mechanics of a vise, but when we cut the pocket in a soft jaw, we have to have the vise clamped on something. We can't just randomly leave it open, because the movable jaw, whenever it clamps, it also pulls down into the bed of the vise. There is a negative angle in there that it pushes down. There's a little ball with the little round thing on it, and it basically pulls it down into the bed of the vise to keep it down in Z. Okay? So we have to have it clamped on something. I use parallels typically. So I'll pick different size parallels. If I need something wider, you might see me with 1, 2, 3 blocks. Something of a known value. Okay, something that I could stick in there and I know how wide is that vise open. Okay, so parallels typically. So for this being a small part like this, we're going to use what I would call my minimum amount. I'm just going to open it up the width of one parallel. So one parallel stood up, one of the 1/2 inch tall parallels stood up on the end. They are an 1/8 inch thick. So I'm going to basically tell it in Y here, I'm going to add a 1/16 to that. That moves both of them a 1/16 further, which means there's an 1/8 inch gap in between there. And then I'll tell it, okay, there is what my jaw geometry is going to be.
So whenever you put the part in there now, there's going to be that little gap.
Yep. We're going to cut the pocket with that opening, and then we'll take the parallel out, and when we put our part in there, that's what's going to let it clamp.
Oh, so we're always going to have a gap right in the middle?
Yep.
Oh,
okay. All right. Now, we're going to take the part, and I'm going to rotate it around just like this. Basically flip it over to where it's like this on your screen. So from your top view, just take and hold down your middle mouse button and rotate it forward and flip it over. Okay. Because now we've got to create the plane for side 2. All right, so we've set our depth. We created our bounding box. We opened up our vise jaw and figured out our gap between them. Now we're going to set up the side 2 plane. So we're going to go to planes. We're going to create a new plane from geometry. And I'm just going to pick this over here would be the corner of my fixed jaw. So I'm going to pick this corner. Pick those 2 lines, and then if you have to if you pick this one first, you might have to hit the black arrow, but get your X and Y flip to where they're going in the right directions. X to the right, Y straight ahead, Z going straight up. We'll tell it okay. We'll name this plane my side number 2 origin soft jaw corner. Everything we do on side 2 is going to be based off of the corner of the soft jaw. So we're going to cut the pocket in the soft jaw, which is going to locate our part, And then everything else on the side 2 operations is going to still be based off that soft jaw corner. We're going to program it, everything off that origin. Okay. All right, so we'll go down. We're going to set our work offset to a 0. Actually, let's set this one to 1. We'll set the G55. We want to tell it to set WCS, tool plane, and construction plane as our active planes down here. And then if we check mark out, you should see it. Make that your active plane, and your origin goes over there. If you go to the View tab and you turn off your world axis, you can see that there. Now I like to also keep on, if you hit Alt F9, maybe? No, not that. Where are they at? Huh. I thought it would turn this on. Display, I like to display my C-plane and tool plane in the corners. I do like to see those. I thought Alt F9 turned those on and off. All right, so that's how we create the plane for the soft jaws. Now we're going to create the soft jaw geometry. Okay. All right, I'm going to go hide this tool path so it's off my screen. All right, we need a pocket that we can locate that part in the jaw. So if you set your Z, if you go down here and pick the Z and you set it off the bottom of this part, what's it set to? Huh? If you click on Z and you pick the bottom of the part down here, what's it set to? It better say -310.
It does not.
It does now. It says 0 a second ago.
We're going to create another silhouette boundary. Select the part. Hit silhouette boundary. Make sure it's arc fit and tell it OK.
Which tab do you find the silhouette boundary again?
It's in the shapes. Yeah, when you click on your solid, it's in the shapes.
Click on your part.
Oh, okay.
Yeah.
There we go, silhouette boundary. Now we're going to check it. Check mark.
Okay.
Ah, perfect.
All right. I'm going to go to my levels. I'm going to turn off my solid so it's out of my screen. I'm going to go to my top view. All right. So the first thing we've got going on, remember I was talking about undercuts. When I talk about undercut, if we cut a pocket this shape into this jaw, right here would be what we'd consider an undercut. It's coming back into itself. So what I'm going to do is I'm going to draw a line. So you're all going to do this with me. We're going to draw a line coming straight up off of this. So I'm going to let it go tangent, and then I'm just going to draw a line straight up off this. No designated amount, just up here a good ways. I'm in my top view, just looking straight down on top of this. Then I'm going to draw a second line. I'm going to come tangent off of this arc right here. Let it snap to this where these two intersect. See how it snaps to that intersection? You got to be in the top view looking straight down over it for that to do that. If you're at any angle, since those are not at the same Z depth, that won't work very well.
I'm just going the opposite way.
For the tangent, just kind of dance it around and it should flip for you.
Oh,
All right, we're dancing. We're dancing.
do a line parallel.
So once we have that, we're going to go up and divide, delete. I'm going to take out this section, and then over here, I'm going to trim out all of this. Don't really need any of this. I don't need these circles. But basically all I'm left with is that right there. It looks like a little boat or something. I don't know. Okay. We're creating a pocket that we're going to hold this in.
What do you mean by undercut? Mr. Benner, do you
So if we were to let this cut backwards into this jaw like this,
You can't open
that part would not slide in, that jaw would not open. Does that make sense? The jaw's got to be able to, part's got to kind of locate itself and open and close. Yeah, it can't have fillets. I just did it. I had it paused from where I walked back to talk to you. I just unpaused it. All right, so we've got a fillet that's going to have interference. We've got to do a clearance fillet. So we're going to come in here. We're going to go to clearance. We're using that 1/4 inch tool, so I'm just going to make the radius a 135, just a little bit bigger than the radius of the tool, 10th thou bigger. And then it's going to go between this straight line and this straight line. And then same thing down here, this straight line and this straight line. And then one more, I'm going to go ahead and put one on this intersection we created over here. All right. And I can take these two little pieces that were left behind, I can select them and delete them. And then I'm going to turn my solid back on so you can see what this is going to look like when the jaw is holding on to it. So the jaw is locating it left to right. It's using this angle here and kind of the back side of this. It's using this radius here and this angled face here. That's locating it front and backwards. We've got this face here and this face here. You know, we're going to cut that pocket to locate and center that part where it's supposed to be. Okay. Does it have to be in the center of the jaw? No, it could be all the way on the left-hand side of the jaw. I could do this same thing, and I could have had these jaws. Okay, and I don't want you to do this. We're just going to put these in the center, but I could have these jaws and say, hey, I want to put this all the way over on the left side.
Then you could have another dot, another thing in the jaw.
Another setup.
You can run multiples.
Yeah, I can move it all the way over. Okay, and then I could have, I could have 3 pockets cut and do 3 of them at once. Okay, yeah.
Couldn't you just like tell it like be 1 inch over then when you like write the code, you just tell it to go over 1 inch and then just start program over again or something?
Yeah, you can it's a transform function we're going to talk about.
Is it,
Okay, so
is it much more difficult to program multiple parts in one code, or could you just do the one and copy it multiple times over?
usually we just do the one and copy it multiple times over. We do the one and what they call transform, translate it. Toolpath transform, sorry.
That's a
Yep.
different tool.
Yep. All right, so I want you to save this. I want to show you this other part real quick. Man, I opened it yesterday, but I don't see it in here. So, let me see if I can find it.
Instructor's eyes open. The intimidation factor. I like it.
Well, you can't get in it anyhow.
Legos. Why are they so expensive?
Okay.
What the?
So this is a 4-station jaw we cut. Now they're pretty simple square pockets, nothing crazy about them, but we start out with the solid stock, okay, and come in there and mill out of a little cube. We mill that part, then we flip it over, goes in here and does the bottom pockets, then it comes in and engraves the logo on one side. And I think that just actually does a transform.
That's a lot of contour.
Can you buy these?
I play with them.
They probably don't work. That's the link is really good.
Oh no, you know what we did? We actually we figured out what this point was right here. And we actually wrote a conversational program to where you could actually go in and engrave your name. Everybody could put their own name on them. So we were doing this as a demo part, and so a kid could come through during the car show or whenever, and they could literally go in and type their own name in, run the Lego, and then take it out of the machine completely finished with their name on it, and get to see how it was made.
$2.
I think we were giving these away, but it's a neat thing for everybody that plays with Legos. All right, but that's what I would consider a progressive. Okay, that's a progressive fixture situation. Okay. Yes.
So pretty much to get the basic outline hard for a soft gel, you're basically just like creating a simplified version of the outer profile of it.
Yep. Just what you'd be looking at the top object lines of the edge. Yep. So 6 by 1 for us, but most time it'll be 6 1/4 by 1, or whatever size your jaws are. Yep. All right. So that's the soft jaws. Okay. We're gonna come back next time. Next class, we're going to come back and we're going to create the tool paths for the pocket and for side 2, and we'll see where we're at to create the tool paths for the face to stand that up and do this bore down in the end. That's the fun part. You will. We are gonna learn how to do it. Okay. All right.
I'm
So-
guessing that's where a 5-axis would be really handy. You just see the stage
Yeah.
right there.
What is a 4-axis?